You can also make the camera controls have its effect. As you can see, it's locked right now because it's taken it exclusively from the expression. Okay, of course, you got the Z channel still unlocked, but X and Y are pretty much ignored by Messiah due to the expression system. So what you can do is simply change it to additive on a channel basis. Okay, so now if you move the X and Y, you can see that it's being added on top of whatever you set in the no. Okay, pretty cool. That's obviously just scratching the surface of what you can do with Messiah. Okay, driving a camera using an O, it's nothing compared to what you can do with its function. So investigate the functions from the function list. A good way to do that is right-clicking on the command tab and click on view function list. It's gonna pop up a list with every function and the parameters that it takes to customize your animation and character rigging. One last thing before we move on. Things are generally activated using the left mouse click and deactivated using the right mouse button click. So if, for instance, you use stereoscopic view mode, you want to untoggle it, just right click on the relevant control and you get it. Okay, after this quick presentation, let's learn how to actually export this to other applications. First, let's reopen our Butch 01 FXS scene. Now let's export it to FBX format. Go to the Customize tab. Here on the left, you're gonna find multiple options. Don't miss checking onion skin once you have the time. It's a great and unique feature in Messiah Studio. But for now, let's select FBX export. Select your export format. I use the FBX text standard. Now make sure mirror X, it's selected. In the global export settings, make sure you save the bone skinning data, which is actually the most important thing we're gonna get here. And if you have some UV data, select Save UV Data. Please notice that the current release of Messiah Studio has a little bug, so that it only exports one material. If you want multiple materials, you might need to go through Lightwave, Maya, XSI, or whatever other 3D application to pull it off, okay? If you want bone deformation, which is our case, do not select the last option, because point cache and bone scanning are pretty much either or options as it is right now. Okay, so last thing would be selecting in the file path. I have created this folder here to make it easy for us. So just select the name of the file you want. Clicking save on that window will just affirm the name, so it should be okay instead. Anyways, you gotta click on export file now, making sure that your end frame is correctly set to the last frame of your animation side by side. As soon as it's exported, it's all set to be used in another 3D application. So let's switch to Maya. Make sure we have the FBX plugin activated. So just click on Windows, Setting Preferences, Plugin Manager, and check if FBX Maya MLL is loaded and optimally auto-loaded as well. Okay, so just close it. Now we're ready to import the file. Just go to File, Import. Let's navigate to the intended folder and select the FBX file. You can see a couple errors here, but there's nothing really major. It's just telling you that a couple nodes, or bones in this case, aren't assigned to an explicit weight, which is absolutely not a problem. And also that Messiah didn't offer an initial binding position for the skin, so one will be computed automatically. Okay? I generally tend to make sure the first frame is in the bind pose when I'm exporting to other engines. It's good practice. So we can pretty much ignore those warnings. Let's see what we get here first. You gotta zoom out a lot to see it, which obviously means that we have working units difference. No big deal. Just go to Preferences, Settings, and make sure your working units are set to meters. Save. And let's switch the viewport rendering mode to smooth shade all, just so we can better see what's going on. Okay, as you can see, the morph targets, or blend shapes, like Maya calls it, are being exported as separate objects, which might or may not be useful. In our case, let's switch to Perspective Outliner View Layout, shift-click the Hierarchical Collapse button right next to our object, so we can check all its bone hierarchy, and you see it has a V-clustered child, just like in Messiah. If you check the item list, you see it has a V-cluster here, okay? We don't want this at this time, so let's just delete it. Now, we want to see the joints, which are inside the mesh. To do that, go to Shading, select X-ray Joints, and there you have it. To get the mesh smooth, select it, making sure you're in Object Selection mode and not in Component. Go to the Attribute Editor, select Smooth Mesh Options, and turn on Smooth Mesh Preview. Now, you can see that things are doing pretty much as you have them inside of Messiah. Let's just extend the timeline to 120 frames, hit play, and you can see that it exported flawlessly, all the weights, all the animation. The best part, it's definitely the automatic generation of the weights from the procedural weighting system of Messiah, which is definitely one of the best in the industry. So to check it out, let's just get back to Perspective View Layout, and let's temporarily hide those joints from our view, and with the object still selected, right click on it and select Paint Skin Weights 2. Now you can see that all our weights, or influences as they're called in Maya, have been flawlessly ported to Maya, what towards us with really good deformation without any weight painting, which is a huge time saver. We can check, for instance, specific pose, let's say frame 89, then check on Messiah, the same frame, and you can see how the deformation is pretty much the same. To be able to use the same camera from the Messiah scene, let's just select here the outliner, select the imported camera from the FBX file. As you can see, its motion is baked just like that of all the other joints. So to see through it, let's select Panels, Look Through Selected Camera, and here you can see that we have exactly the very same viewpoint than that of the Messiah scene. Okay, you might need to change some properties from the camera depending on if your import was 100% successful or not. To do that, you would select the camera unit shape, this guy here, and make sure that your view angle, focal length, and all those attributes properly correspond to what you get in Messiah. Many times though, you won't have to touch anything. One of the advantages of Maya is the dual quaternion scaling method. So to showcase that, let's go to some frame where we can force or cause a pinching to occur. Let's get back to Perspective View and select, for instance, this joint, and let's quickly disable Alt key so we don't make anything by mistake, and just rotate it to force a pinch. Let's twist the view a little bit. Okay, here you can see clearly the pinching, which is a result of the linear scanning method. If I go to Messiah and head to the same frame, 81, and turn it on the bank, just like what I did in Maya, you'll see the exact same result. The difference is that in Maya, I can select the mesh, head to the skin cluster node, and switch from classic linear to dual quaternion. And you can instantly see how better it preserves the volume, which doesn't only affect pinching regions like that, but it actually affects the whole mesh. Like you can see formations in the back, and any too tight area is going to have its volume much better preserved using dual quaternion. That is surely something I expect to see more in other programs in the near future. Okay, enough of Maya. Let's have some fun with Lightwave. The first thing to do is go into File and Loading. Just like a regular scene, yet we'll be importing the FBX file instead. Once the requester shows up, you can change the content directory. I'll just leave it as default, and you can scale the scene if you want. I won't do it. I'll just leave it on standard scale. Once the import process is complete, let's clean up the scene like we did in Maya. Delete the sentence as well. Let's turn on headlight so we can better see the scene. Switch to the front of it. Select the geometry. Go to Modeler Tools. Switch G-Toggle Subpatch so we can see it smoothed. Still with the object selected, I'll hit Ctrl-A for its properties. Ctrl-A, by the way, it's a shortcut from Light keys. If you're not using it, why not? You can also double-click the object to get to the same window. So what we want to do here is reduce a bit the display subpatch level and set the subdivision order to last. Differently from Maya though, because you have a couple steps before things are done. As you notice, once you scrub the timeline, you can see that the skeleton is animated, but the mesh is not being deformed by it. The reason is that the joints aren't active. So let's go to the Setup tab where we do everything rigging in Lightwave. And before we make any extra step, make sure your Auto key is off. So the first thing we could try is go to Bones and activating the bones. But look at that. The whole mesh is screwed up. What happened? The reason for that is that the Valkyrie importer from Lightwave by mistake, not sure if it's on the Lightwave and or in the Messiah exporter, because both are actually work in progresses. The fact is that the Valkyrie importer decided to record the pivot rotations for those joints, which is bad when you're importing FBX animation. So to fix it, it's pretty simple. Just go to More, Orientation, and remove recorded pivot rotation. Once you do that, Lightwave will warn you that it's gonna remove all pivot rotations from the model. Well, that's what we want. Click on OK. Now we can activate the bones, and as soon as you hit play, you're gonna see that the animation is working. But there's something to watch here. What you're seeing, it's actually Lightwave's standard bone deformation. It's completely ignoring the Messiah's generated weights, which is definitely not what we want. Although it's curious to notice that it does a really good job. As a matter of fact, Messiah's procedural weight generation system branched off from Lightwave many years ago, but it evolved from there, and that's what we want to use. Okay, so how do we do that? Well, let's check what we've got here. First, let's turn on Bone X-ray and start investigating our skeleton. You notice right off the bat that there are duplicate names here on the scene editor, always at the tips. So for instance, you've got show plate and show plate 2, with just shoulder plate if you check in the Messiah scene. Okay? The reason for that being that Lightwave defines a deformer between joints, so it needs a kind of a placeholder joint, but once it imports the file, it has to duplicate the name of the actually relevant joint.